Europe, an ancient continent. Within its borders lies an unrivaled richness of both natural and human wonders. At its northern limits, Europe reaches into the icy wastes of the high Arctic. To the south and west, its fringes have been shaped by the Mediterranean Sea and Atlantic Ocean. Far to the east, it is bounded by the primeval forests of Russia, rubbing shoulders with Asia. These boundaries enclose an area just half the size of North America, yet 730 million people make Europe their home. It's hard to find a space unmarked by human occupation. The Europe that we see today is the product of a long and complex history. Thousands of years of settlement, invasions, revolutions and inventions have allowed us to reorder nature's ancient patterns to suit our needs. On a human timescale, the story of the changing face of Europe seems immense. But there's an even more extraordinary story to be told, one that stretches back 500 million years and tells of the events that have really shaped the continent. 8,000 years ago, the skyscrapers of Frankfurt would have risen over endless primeval wildwood, stretching from Lisbon to Leningrad. Over the last 2 million years, Europe has seesawed between perishing cold and stifling heat. During the Ice Ages, Amsterdam and London would have been smothered by huge glaciers. And at other times, they'd have looked more like Africa's Serengeti plains. More than 50 million years ago, what is now Vienna and Paris would have been submerged beneath rich tropical seas. And over 100 million years ago, Florence and Oxford would have looked more like Jurassic Park. Go back over 200 million years, and Europe rivaled the Sahara. And 300 million years ago, the world's first forests covered the continent. Berlin would have been part of a tropical rainforest. Edinburgh sits astride ancient volcanoes which shook the earth nearly 500 million years ago. All these great events helped to lay the foundations for the extraordinary continent we now call Europe. The northern fringes of Europe are its wildest country. Scandinavia, a land dominated by the elements. In summer, it's bathed in the glow of midnight sun. And in winter, by the ghostly shadows of the northern lights. In this coastal labyrinth of fjords and islands, Europe's most ancient history lies hidden. Norway's Lofoten Islands, seemingly lifeless, but they're surrounded by the richest of seas. Here, Atlantic storms pound some of the most ancient rocks in the world. They're nearly 3 billion years old. These granites formed long before the European continent even existed. Here, in Norway, there are also clues to Europe's birth. These fjords and mountains are part of an ancient range, the Caledonides, stretching from Ireland to Scotland and up through Norway. Mountains that today help define the continent's western edge. In the east, another ancient range, the Urals, separates Europe from Asia. Both these ranges are evidence of Europe's earliest formation, the result of processes that began 500 million years ago. Back then, Europe was still in pieces. Scandinavia was in the southern oceans. England and the Low Countries were near the Antarctic Circle, and most of the rest sat near the South Pole. All of these isolated fragments of crust were on the move. Continental plates are dragged along by powerful flows of molten rock deep in the Earth's mantle, some 80 kilometers underground. They only move a few centimeters every year, but over millions of years, these centimeters add up. Like a giant jigsaw puzzle, Europe was gradually assembled, piece by piece. Each impact created enormous crumple zones. Rock was bent and buckled, as if caught between the jaws of a vice and forced up into great mountain chains along the join. They created Europe's backbone, which in scale once rivaled the Himalayas. The formation of these ancient mountains was the first act of European union. Since then, Europe has traveled halfway across the globe. 300 million years ago, it was straddling the equator. In this warm, wet climate, the foothills of Europe's oldest mountain ranges now became the cradle of the world's first forests. Paris would have been smothered in lush tropical rainforest, which stretched east across the entire continent. This was no ordinary forest. What looked like trees were in fact giant ferns, horsetails and club mosses, the fossils of which have been exquisitely preserved in this Scottish park. They offer a glimpse of the botanic wonders that once filled Europe's ancient forests. These club mosses grew a massive 30 meters tall. Long before birds appeared on the planet, these carboniferous forests would have echoed to a very different dawn chorus. Predatory dragonflies were common, and some were absolutely huge. This one, Meganeura, was the size of a hawk, with a wingspan of over 60 centimeters. The forest floor was a bug's world too. Fossil footprints of a millipede show that it was nearly 2 meters long. Over 800 species of cockroach scurried through the ancient undergrowth, and these were preyed on by other giants, like scorpions. Some were over 70 centimeters long, with a sting to match. These swampy forests were also roamed by the very first land vertebrates, amphibians. The Carboniferous era was to play a pivotal role in European history. Its 300-million-year-old legacy would eventually revolutionize the modern world. This was a time of great tectonic activity. As the land repeatedly subsided, seas flooded over these great coastal forests. Ravaged by monsoon storms, fallen trees became buried by layers of sand, then mud. Over millions of years, the buildup of sediment compressed this vegetation into this: coal. It took a 10-meter layer of fallen rainforest to make just a 1-meter seam of coal. When you consider the depth of all the seams in all the coal fields worked in Europe, from Britain through to northern France and Germany, Poland and Ukraine, the immense scale of carboniferous forests becomes clear. Coal fueled one of the greatest transformations that Europe has ever seen. Its presence all across the continent was a vital component in making Europe the cradle of the Industrial Revolution, and ultimately turned it into the economic powerhouse it is today. The ancient past can directly shape the present. Europe is now the most urbanized and industrialized continent on the globe, largely thanks to its position on the equator 300 million years ago. When these steaming forests were at their peak, other events were already in motion that would banish them forever. Europe, still drifting north, had been rocked by another series of monumental collisions, and the result of the tectonic pileup was this: the supercontinent Pangaea. Around 230 million years ago, Europe was engulfed by a mass of land. Now, far from the oceans, rain no longer fell. Under an unforgiving sun, the lush tropical forests disappeared, and the continent was swallowed by sand. The fossilized remains of these desert dunes now form much of the bedrock of Eastern Europe. In the depths of a Russian winter, it's hard to imagine how hot and dry this place once was, let alone some of the creatures that roamed here. Dinosaurs, a new order on the move. Parts of Pangaea were periodically flooded by shallow seas. But time and again, this water evaporated, leaving layer upon layer of salt. Today, these massive deposits lie buried deep beneath the Netherlands, Poland, northern England, and the Austrian Alps. They've been mined for millennia. Salt is a major ingredient for the chemical industry. It's also used, albeit controversially, to de-ice Europe's roads in winter. Thousands of tons a day. This particular mine, in Krakow, in Poland, is made up of over 300 kilometers of tunnels. It's so vast that miners have carved an entire underground cathedral out of the salt. Even the chandeliers. After tens of millions of years of baking under the desert sun, Europe changed once again. This is the Jura in eastern France. The slopes here are blessed with fertile, well-drained soils, perfect for vineyards. And scattered among the vines are clues to the next waves of change that began to sweep Europe some 200 million years ago. A fossil ammonite, a marine creature, and mussels, even the ancient relatives of squid. This area was once under the sea. These waters teemed with life. As well as ammonites, marine reptiles called ichthyosaurs were common. They fed on fish, breathed air, and gave birth to live young. They were the dolphins of their time. All these creatures swam where there are now thousands of vines. And it's this region of France that has lent its name to one of the most familiar periods in the Earth's history: the Jurassic. What had once been covered in dense forests, then by desert sands, had now become a paradise of tropical seas and coral reefs. But what was the catalyst for such dramatic change? The answer, once again, lies with the ever-shifting continents. Just as they can collide, they can also split apart. And when this happened to Pangaea, water flooded into the gaps, creating new coastlines and oceans. the newly liberated Europe still lay in the subtropics, and the seas surrounding it were warm, shallow, and clear, ideal for corals. Fossilized reefs show these seas flooded all across Europe and remained there for 70 million years. In these warm waters, more of Europe's foundations were laid down. Corals, shells, and lime-rich mud were slowly deposited onto the sea floor. Millions of years of deposition and compression resulted in this: limestone. Limestone grew in the sea, but was shaped by rain. Rainwater dissolves limestone, drip by drip, grain by grain. A very simple chemical reaction has sculpted some of Europe's most breathtaking scenery. And limestone is also perfectly suited to be carved by the hand of man. This rock and its derivatives, like marble, provide wonderful building material. The legacy of the Jurassic seas are some of Europe's most stunning and celebrated man-made and natural monuments. The dreaming spires of Oxford are built almost entirely from Jurassic limestone. Local masons often ice this architectural cake with flights of fancy, from gods to gargoyles. And when this rock was quarried, it also revealed traces of real monsters, the bones of huge dinosaurs. 170 million years ago, Oxford was a real-life Jurassic Park. Dinosaur fossils have been found throughout Europe. In Rioja in Spain, the traces they've left are not only the bones. Hundreds of dinosaur tracks have been discovered in this mountainous region, some revealing an ancient struggle between predator and prey. A deadly drama from the age of the dinosaurs, frozen forever in a layer of rock. As reptiles conquered the skies above ancient Europe, dramatic changes were affecting the western shores. Pangaea continued to disintegrate. Europe was tearing itself away from what is now North America. This separation gave birth to one of the world's great oceans, the Atlantic. As this ocean grew, pterosaurs were not the only creatures exploring the air. And the most famous evidence for that is found here in Solnhofen in Bavaria. This tiny community is famous for the unique qualities of the local rock. The limestone quarried here is extremely fine-grained and can be worked into thin and very light slabs. They make perfect roof tiles. But these tiles occasionally reveal something extraordinary. Perfect snapshots from 150 million years ago. Back then, Solnhofen was part of a very still and salty tropical lagoon. No scavengers could survive in these toxic waters, and anything that died was left undisturbed. One casualty in particular has made Solnhofen world famous. Archaeopteryx. Although it had the head and pelvis of a reptile, the long forelimbs suggest something altogether different. They're covered in feathers. This was part reptile, part bird. Archaeopteryx marks one of the major turning points in evolutionary history. From these beginnings emerged the 9,000 species of birds that fill the skies today. The next great event that Europe experienced took place 100 million years ago. The clues lie hidden in the famous chalk cliffs of southern England. Chalk is composed of the shells and skeletons of ancient marine plankton, microscopic creatures, trillions and trillions of them. As they died, they slowly sank, settling in layers on the sea floor. Through time, they formed these cliffs in an ocean that was up to 300 meters deeper than we see it today. Just imagine how London might have looked back then. All this flooding was triggered by rising seafloors and a warming climate, causing the ice caps to melt. A cataclysm that resulted in much of the continent disappearing. But it wasn't these rising seas that spelled the end for the dinosaurs. It was an event that happened 30 million years later, and half a world away. A giant meteorite crashed into the Gulf of Mexico. The destructive power equaled 5 billion Hiroshima bombs. Shock waves swept across the Atlantic. All across Europe, life struggled to hold on. The extinction of the dinosaurs created opportunities for new forms of life, evidence of which can be found here on the Baltic coast of Poland. These fishermen are after a catch that could change their lives. They're not after fish or crabs, but something far more precious, washed up from the seabed. One lucky dip could net a small fortune and open a window back more than 50 million years into Europe's past. This is amber. It doesn't look much until it's polished. Then it can reveal all kinds of treasures. It's the fossilized resin of ancient pine trees, and trapped within it are perfectly preserved souvenirs, each fragment helping to build a picture of an ancient world. This resin has also trapped something that marks a great turning point in evolution: hair. Its presence indicates the rise of a new dynasty in Europe, the mammals. These subtropical forests were home to a huge variety of these creatures, from kangaroo-like carnivores and tapirs to anteaters and even miniature horses. 50 million years ago, the mammals were evolving at an astonishing rate. From just one site at Messel in Germany, dozens of different species of fossil mammal have been unearthed. Today, their more recognizable descendants occupy virtually every niche right across Europe. As Europe's new fauna took center stage, the continent itself was undergoing another decisive step towards completion. Signs of this can be found here on the western fringe of the continent, along the remote cliffs of Ireland and northwest Scotland. These spectacular coasts are built of compacted volcanic ash and lava. They are visible remains of ancient eruptions that cover thousands of square kilometers and mark the growing pains of a young ocean. 60 million years ago, North America and Greenland finally split apart from Europe. As the continental plates separated, the North Atlantic was born. It's a process that's far from over. Now 5,000 kilometers wide, this ocean is still expanding at the speed our fingernails grow. This is happening all along the mid-Atlantic ridge. Occasionally, eruptions here are immense. Volcanoes rise up from the abyss. Iceland is just the tip of one such volcano. Its violent volcanic history is written all across the island. New eruptions happen all the time, adding new territory to this isolated European outpost. These are some of Europe's youngest rocks. The events here in Iceland reflect the violent processes that have helped build Europe over the last 500 million years. Despite their violence and unpredictability, volcanic foundations do have advantages. The Icelanders put all these hot rocks to good use. A borehole sunk deep into the ground taps into all this heat and uses it to power much of the island. And a byproduct of this natural central heating is this, the Blue Lagoon, the biggest hot tub in the world. As the North Atlantic grew, Europe's northwest coast was taking shape. But in the south, the continent was still missing some key ingredients. 60 million years ago, the Alps didn't exist, and the Mediterranean coastline looked very different. One last great push was needed to mold the continent, and it came from a neighbor to the south, Africa. The African plate has been drifting north over millions of years. And where it pushes against the European plate, huge folds of rock have been forced up and over one another into great mountain ranges. Europe's southern mountains, the Pyrenees, Carpathians, and the Alps, all rose from this collision. Pieces of primeval ocean floor have been lifted thousands of meters up into the sky. The Alps are still rising as Africa continues to push north. The volcanoes of southern Europe are vivid reminders of the great tectonic forces lurking beneath our feet. Vesuvius in southern Italy is a sleeping giant. Nearly 2,000 years ago, a huge eruption buried Pompeii. Today, the city of Naples lies sprawled across its lower slopes. Who knows when another nudge from Africa will set it off again? It isn't just Europe's southern mountains that owe their existence to the advancing African plate. So too does the Mediterranean Sea. This sea is one of the defining boundaries of the continent. With its spectacular coastline and clear blue waters, it's one of Europe's great natural treasures. Much of the Mediterranean's extraordinary history hinges on the narrow seaway at its western end. At the Rock of Gibraltar, only 14 kilometers now separate Europe from Africa. About 6 million years ago, the northward push of Africa, combined with a drop in sea level, created a vast dam, cutting off the Mediterranean from the Atlantic. As the sun beat down, something like 4,000 cubic kilometers of water evaporated from the Mediterranean surface every year. And with no Atlantic water to replenish it, the Mediterranean dried out. In just 1,000 years, it became a desert basin of salt pans and caustic lakes. The rivers that once fed the Mediterranean cut deeper and deeper into the rock, chasing the dropping shoreline and forming a labyrinth of dramatic gorges. Just a few million years ago, France's Rhone Valley must have looked more like the Grand Canyon. So intense was the heat in the basin that these waterfalls evaporated before they even reached the old sea floor. For tens of thousands of years, a natural dam between present-day Morocco and the Rock of Gibraltar held the waters of the Atlantic at bay. The Mediterranean basin remained an almost lifeless expanse of salt, sand, and parched earth. But as Africa pushed and pulled at Europe's southern boundary, the pressures on the crust became unbearable. Rising tides weakened the land bridge, and then the Atlantic burst its way over the precipice. So began the most gigantic flood ever. At its peak, enormous waterfalls 1,000 times grander than Niagara thundered into the basin. More than 100 cubic kilometers of water gushed past Gibraltar every day. Despite this enormous flood, the Mediterranean took more than a century to refill. But what is more amazing is that this process of drying and flooding has happened not just once, but possibly 10 times. With this flooding 5.5 million years ago, Europe's southern borders had now taken shape. The final act in the genesis of the continent. A chain of incredible events has shaped Europe during its long and dynamic history. It's a history that's written across the face of this unique continent. A story that began billions of years ago, south of the equator, and which charts an incredible journey across the face of the globe. The diversity of Europe's landscapes today reflects the changing conditions encountered along the way. Each has left a unique fingerprint on this small but incredibly complex continent. For eons, the birth of Europe had been driven by geological events. But now a new and different force was destined to shape the land. Two million years ago, Europe's climate spiraled out of control. Temperatures plummeted. Consumed by glaciers, the continent would now be plunged into one of the most extreme eras in its history. The great ice ages were on their way.